We have Unit 2, Lesson 6, Part 2, the solving radical equations part. We did the restrictions yesterday, got a little carried away with that. But yeah, so we're going to look at the calculator piece here. I do have the TI-84 up here so you can follow along. But consider the radical equation root x plus 1 equals 4. State the values of x which the radical equation is defined. So let's do the define part first since we should know how to do that. So it is defined if it's x plus 1. Remember, we kind of want to set that inside greater than or equal to 0 because it can't be negative. And this is simple, just minus 1. So we want greater than or equal to -1 is where that equation is defined. What that essentially means is that on your graph, you're only going to have values from -1 positive, from here all the way over here. Okay, that's the only places we're going to have stuff positive. Okay, I want to keep that on here, keep our graph a little bit clean. Okay, and so then it says, explain how to use a graph calculator to find the solution of the equation by using the intersect feature on your calculator. So basically, and if you haven't used this feature before, we are going to treat these as two lines. We're going to treat it as this in our y1 and this in our y2. And then we're going to figure out where they cross. Okay, so I actually have them in here already. So if we go to the calculator, so this is what it looks like. So I put root x plus 1 in the y1, 4 in the y2, and then I'm going to hit graph. And then you're going to see that you can't quite see them intersect over here. They're not quite intersected. So what I'm going to do is I'm going to go ahead and minimize this for a second because the book actually tells me what window to use. Okay, it tells me to change my window, -3, 21, -5, 5, 1. Now we'll put that in, but the other thing I want you to understand is if you ever run a test or anything and you are trying to do something like this and you can't see the intersection, you have to kind of intuitively see, I need more x's. Let me kind of show you here. I'm going to write on it for a second. Because obviously I want to go over here, so I need to increase my x value. That's why they increased it. And I really don't need all this. Okay, we know it starts right here, -1. So that's why they went -3 to 20. Okay, so let's try that here. So we're going to go window, x min, let's change this to -3, 20. We're going to go down here for the y min, and we're going to go -5 and 5. Okay, now let's look at the graph. Okay, now we see the intersection. So we feel pretty good about that. So now what we do is we hit second trace. Okay, and if you're following along with me and you don't hear or see exactly how I push, it's right here below in the key press history here. So see down at the bottom, second trace, that's where I'm at. Okay, and so we're going to do intersect, which is number 5. So you can hit a 5 or you can arrow down to it, whichever. Okay. Now the intersect feature is actually pretty easy to use. It does most of the work for you. All you do is, it says first curve, question mark. That just means is it on one of your first curves? It is. It's on my radical equation. Just hit enter. Then it says second curve, question mark. And is it on your other line that you're looking at, which is the y equals 4 line? It is. Just hit enter. And it says guess. You don't have to get too close, but I like to. Just kind of arrow over so you're close to where they cross. Okay, and then hit enter. And it tells you the solution is 15, 4. So that means the answer to that equation is 15. We knew it was 4 for the y, right? Because 4 is what it's equal to. So essentially, an x is 15, y is 4. So if we look at that in terms of the workbook, okay. So explain. So let's just briefly recap what we did. In your y1, you're going to put the radical equation. In your y2, you're going to put the 4. And then you're going to use the intersect feature to solve. Okay, and we did that. We got, so the 4 line is right here. And then it was 15, so they're going to intersect there. And so it goes something like this. That was the picture that we just saw. Okay. State the solution to the equation. So x equals 15. Verify the solution algebraically, so just plug it in. So if I plug 15 in, you'll kind of see, oh, that makes sense, because 15 plus 1 is 16. Square root of 16 is 4, so you get 4 equals 4, so you are verified. Okay, so that's the graphically way of doing it. Okay, let's go ahead and go on here. Okay, investigation 1. So solving radical equations algebraically. Complete the following steps to solve the radical equation and verify the solution. Remember I said yesterday we do have to verify. There's extraneous solutions in which aren't real. We get those, but they don't work. And that a lot of times has to do with your restrictions. Okay, you may get solutions that are outside your restrictions, so those don't actually happen. Okay, so square both sides. So we're solving the one we just did. So we're trying to get x by itself. So we're going to follow those same steps and get x by itself. So we square both sides. So you get x plus 1 equals 16. And you're going to minus 1, where x is 15. Going to verify our solution. Okay, so we plug in the 15, which we already got this, so this is just kind of redundant. We get 15 plus 1 equals 4. Sorry, it's a bad plus there. 15 plus 1 is 16. Square root of 16 equals 4, which is equal to the 4 we have there. So we just verified. Okay. Okay, so it worked out there, so that's the good news. Okay, but we do need to kind of look at it from a little bit different lens. On the next one, we're going to really look at it in more detail. This is where it gets a little bit more difficult. You got a little bit more foiling to do, got a little more algebra to do. So this is where you can say it gets a little bit messier here. So this one we're going to go ahead and we're going to solve again, but we're going to add a 3 in there and an x on the other side. So now we have 2 x's. Okay, so that makes a little bit of a problem. So what we need to do is just still have to get the radical to go away. So if you want steps, we do have to isolate the radical term and square both sides. You need to do that because we have to get that x undone from the radical. Okay, so we do that first. So if you see up here from the equation they worked, they subtracted the 3 first, and now they're squaring. So to square this, we have to FOIL, right? Don't make that simple mistake. The thing is x squared plus 9. You got to FOIL it out. So that's going to leave us with x minus 1 equals x squared minus 6x plus 9. Okay? Now since that's the case, we need to solve. Well, see how there's an x squared there? Immediately, since think about the section we're in, we're going to be solving by factoring. So we've already done that in lesson 5. So we're going to think about, okay, I need one side to be 0, and so I use a 0 product law. Okay? So we're going to go 1 and minus the x. So we're minus x, and we're adding a 1. So I get 0 equals x squared minus 7x plus 10, and I need to factor that. Factor the 10, that gets you 7. That's the nice 5 and 2, both negative. And so with that, you see that the answer is 2 and 5 by the 0 product law, right? The opposites, minus 2 is a plus 2, minus 5 is a plus 5. So you got x equals 2, x equals 5. So we need to verify the solutions to make sure they work. So we'll plug 2 in first. I'll plug on the left side here. Do a little bit of change color so we can see we're verifying. We got 3 plus square root 2 minus 1 equals 2. Okay. So I do that, you're going to see this is why we have to check. 2 minus 1 is 1. 1 plus 3 is 4. Because the square root of 1, right? Square root of 1 is 1 plus 3 is 4. 4 does not equal 2. So this one's not a solution. Okay. 5. Okay, if we try 5, put 5 minus 1 in, we get 3 plus square root 5 minus 1, which is 4, equals 5. Square root of 4 is 2. 3 plus 2 is 5. So this side is good. So this one is a solution. And that's why we have to verify these. It's not just to show your work. You need to verify their actual solutions. Okay. All right. So confirm the above results by solving the equation graphically. So let's go ahead and try this in the graph calculator so you can see me do this process one more time. So we're going to go to y equals. Okay, the equation we just did was 3 plus root x minus 1. Okay, we're going to arrow out. Delete that one there. Okay, so we got 3 plus x minus 1, and then equals x. Okay, probably have to change my window again, we'll see. Yeah, just want to change it just a little bit. I want a little bit more y's, I want a little bit less x's. So let's go to our window. So my x min's fine. Let's just go to 10 here. And then I need more y's. My y min's fine, I don't need to go lower, I just need to go higher, so let's just change it to 15. And so now we can see the solution. Now, the good news is that if you're saying, well, what is that other solution from? How did that come about? Well, radicals are actually half of parabolas. You get into this more into Math 30 and you'll kind of see it. But they're actually half of parabolas in the sense that they actually go sideways, like this. And this value right there is the 2 we got that didn't work. But that's not there. It's not part of our actual equation. So the line thinks it's going through the other half of this because they think this is symmetric, but it's not actually happening. And so that's what we have to verify to make sure it's true and for the equation that we have. So there's your example of us doing it with the calculator one more time. Okay, let's keep on going here. Now we're talking about extraneous. Okay, so just kind of summarize this. So extraneous solutions are those solutions that you get that do not work. We identify those as extraneous. So it says process used in solving investigation 2 led to the answer which is not one of the roots of the original radical equation. However, a root of a non-radical equation step 2 formed by squaring the original equation. So this is because the process of solving a radical equation is based on squaring both sides of the equation. If two quantities are equal, then their sides are equal. The converse, however, is not necessarily true. If two quantities which have squares that are equal are not necessarily equal. So negative 3 squared equals 3 squared, but negative 3 doesn't equal 3. So the converse is why that happens. So again, we know that negative 3 and positive 3 are squared, are equal, but them alone are not equal. So when you're going backwards and you're solving, you may get a 3 and a negative 3, but they're not equivalent. So it's not going to equal the side or the value you're given, perhaps. So this type of answer is called an extraneous solution or extraneous root. For this reason, it's always necessary to verify. So it's not just that extra step you don't need to do. You absolutely need to do it. Again, one thing you can say good things, bad things about books you use. The really good thing about the books for these workbooks, is that step 1 through 4, like all their steps they give you, their flow charts they give you for solving are actually quite good. So definitely get this down. So your first step, you need to get that radical term alone. Okay, we'll talk about 2 radical terms next class. After you get it alone, we're going to square both sides to get rid of the radical. Okay, and then from there, you're just solving. How we just solve by factoring, maybe just it's a regular solve. You just go from there. Okay, so let's go through a couple examples here. Okay, so for these ones, they're already actually isolated. They're single radicals on both sides. So we do have 2 radicals, but these are the easier ones because we're simply just going to square both sides. It's kind of tedious because you're solving those x plus 3 equals 3x minus 5. So we're just going to go square, and so you get x plus 3 equals 3x minus 5. And now we're just solving that back to grade 9. Okay, minus x. I always move the smallest x. You can move whichever one you'd like. Plus 5. Okay, you guys are advanced kids. You can do 2 steps at once. There. There. So we get 3 plus 5 is 8. 3 minus 1 is 2. 2, 2. X is 4. Now, I circled it, but I still need to verify it to confirm. Okay. 4 plus 3 is root 7. Root 7 just stays root 7. 3 times 4, so I'm plugging it into the right here. 3 times 4 is 12. Minus 5 is root 7. So we're still good. So this one is verified. Okay. Very similarly, here we're going to do an x minus 3 instead this time. We're going to square both sides. Okay, so we square both sides, we get x minus 3, 3x minus 5. I'll do the same exact steps, minus the x, I'll add the 5. Okay, so I get 2 equals 2x. Good. We're going to divide by 2. Divide by 2. X equals 1. And then we have to check it. I'm going to circle it, so I have to check it. Okay. So the extraneous could be a solution that's actually not there, not real, or you can get a solution that's not within your restrictions. Kind of spoiler, this is one that's not within your restrictions because look, if I put 1 into the first one, the x minus 3, what's 1 minus 3? Negative 2. We cannot do that, therefore that's not a solution to the equation. Okay, it does not meet the restrictions. Okay, the last one we're going to talk about here is example 4. Okay, solve the radical equation here. So with this one, we're going to go ahead and isolate. This is kind of starting us up for lesson 7. We're going to isolate the more difficult radical. So is root x or root x minus 3 more difficult? Probably the root x minus 3 because it's 2 terms. So we're going to minus the root x over. And so then we're going to have this. This is where you have to get really good with your foiling and algebra for tomorrow or next class. Okay, so here we are. Now we've isolated the more difficult radical. Now we're going to square both sides. Now when you do it this time, you are going to have a radical left, so you have to go back to step 1. It says that in the steps. It says if you isolate a radical and square and you still have a radical, isolate the radical again and square. So we're going to do that. So this right here, left side, we got x minus 3, and we have to FOIL this one out. So I'll come over here and do it for you because it looks a little bit different because it's a radical. Okay, 5 times 5 is 25. 5 times negative root x, negative 5 root x. Negative 5 root x. Positive x. We're going to multiply all that. So you'll see we get 25 minus 10 root x plus x. And so what you're going to do now is you're going to move the stuff that doesn't have a root on it to the left side. So we're going to minus 25, we're going to minus x. The convenient thing here is the x's actually cancel over here, so that gets rid of a term on this side. Okay, so we get that's gone. We get negative 28 equals negative 10 root x. Okay. And so we're going to go ahead and divide the negative 10. We're trying to isolate the radical. Okay, and so that gives me a 28 over 10 reduces to 14 over 5. So we'll just leave that 14 over 5 is root x. And now we're going to square both sides. So square both sides, we should know 14 squared. 14 squared is 196. 5 squared is 25. So 196 over 25 equals x. And now we have to go ahead and verify that. So we take 196 over 25. We're going to put it back into the original here and there and make sure it works. So we'll do that here. Let's switch up the color setting here. So we're going to go square root 196 over 25. And we're going to go plus square root 196 over 25 minus 3 equals 5. So when you square root 196 over 25, you're going to get 14 over 5. Okay. Then this one you're going to get 14 over 5 minus 3. So we got to kind of, sorry, can't do that yet. We actually have to do common denominator first. So we're going to get 3 in terms of 25s is 75 over 25. And so that's going to give me, when I sort all that out, we're going to get 121 on the inside. So 121 over 25 is also a perfect square of 11 over 5. So 196 minus 75 is going to give me 121 over 25, which gives me this. 14 over 5 plus 11 over 5 is 15. Sorry, I keep saying root. It's just regular 5, excuse me, which is 3. Okay. Oh, sorry. 14 plus 11 is 25. Let's say 3 is not the answer, which is 5. Everything else is good. Okay, so we just confirmed it. Sorry, 14 plus 11 is 25, not 15. Okay, that's it for lesson 6. So please do the lesson 6 practice problems. And be ready for lesson 7. It's going to be a little bit longer, a little bit more difficult, and a little bit higher level of doing what we just did here for this problem as well. Okay.